Welcome to Triple S Physics, the total angular momentum operators. The total angular momentum operator can be denoted by the symbol J. So for three different axes, Jx, Jy, Jy. Jz. The generalized angular momentum operator J as any Hermitian operator whose component satisfy the commutator rules Jx, Jy equivalent to IH cross Jz, Jy, Jz equivalent to IH cross Jx, Jz, Jx equivalent to IH cross Jy, Jz, X, Y. So these three equations can be simply written as J for the different axes. So simply J cross J equivalent to IH cross. So here Jx, Jy, Jz. So simply denoted by J. So J cross J equivalent to IH cross J. Quantum mechanical definition of angular momentum can be denoted by J equivalent to H cross R cross P. So here if you are consider the system of units H cross equivalent to 1, this angular momentum given by equation 3 for the commutation rules satisfying the three axes of angular momentum Jx, Jy and Jz. So here Jx, Jy equal to Ijz and H cross and this H inverse cancel and also H cross value is equivalent to 1. So that's what the H cross in H inverse is not coming here. So then Jy, Jz equivalent to I Jx, Jz, Jx equivalent to I Jy. So simply denoted by J into J equivalent to I J. Then commutation relation of total angular momentum with the components. The total angular momentum is represented by J squared equal to Jx squared, Jy squared plus Jz squared. So the commutation relation of J squared with the components of different axes of angular momentum Jx, Jy, Jz can be represented by J squared comma Jx. So initially angular momentum with the total angular momentum and the angular momentum in x-axis J squared Jx equivalent to. So we know the values of J squared from equation 1. So substitute the J squared value here Jx squared plus Jy squared plus Jz squared comma the same Jx value. So J squared and using the commutation rule Jx squared Jx then plus Jy squared comma Jx plus Jz squared comma J. So we know the equation equations AB comma C if the commutation AB comma C equal to A BC plus A comma C B. So this is the basic formula. So apply this formula in this equation. So Jx squared comma Jx equal to, so this Jx squared can be split into two Jx value Jx comma into Jx comma this Jx. So this is A B comma C. So like this equation. So use this equation. So Jx squared comma Jx equal to, so here Jx A, this Jx B, this Jx C. So apply this equation for this commutation rule. So Jx A BC plus AC B equal to 0. So this Jx squared equal to 0. So this term is 0. So from equation 2 Jx squared comma Jx equal to 0. So the remaining this term J squared comma Jx equal to 0 plus this term. So this term is 0. So then Jy squared comma Jx plus Jz squared comma Jx. So again this Jy can be written as Jy comma Jy into Jy. This J squared can be written as Jz Jz. Again this equation like this equation. So AB comma C. So apply this equation for both the terms. Then finally we get this 0 value. So finally J squared comma Jx equal to 0. Similarly J squared comma Jy equal to 0. J squared comma Jz equal to 0. So this is the commutation rules relations applied for different angular momentum with total angular momentum.